Hey, Mr. Kennedy once again. So next we're going to be looking at metamorphic rock identification, and this is on page number 7 of your ESRT. So ensure you have page 7 open up in your Earth Science reference table. This chart is pretty simple and easy compared to the last one that we looked at. This just starts with the first column here, which is texture. Now, all metamorphic rock can be grouped into two different textures. One is the foliated texture and the other is the non-foliated texture. The foliated texture can also be subdivided into mineral alignment and bending. All right, just to give you a pictorial view of what those vocab words means. When heat and pressure act on rock, which is metamorphism, that is what converts any kind of rock into a metamorphic rock, heat and pressure. So when rocks are subjected under great enormous amount of pressure or heat, the minerals that are inside the rocks begin to separate themselves, and then they form lines. So all minerals that are the same come to form one line, the other kind of mineral forms another line, and those kind of lines is what is referred to as foliation. If you look at this here, and if you look at this, if you zoom a little bit closer, you see those beautiful lines that are being formed. If you look at these here as well, so those are the alignments that we are talking about. So those rocks, we can say they are foliated. Okay, and then for these other guys, you see that they are not foliated, which means they are just uniform. Most times it's just because they have just one mineral in common. So look at this non-foliated, you see that it's just simply made up of carbon, or made up of quartz, or made up of calcite. So they only have one mineral, so there's no way one mineral will separate into different lines. Some of them, I agree, do have various minerals, but the heat or pressure was not enough to make them separate into minerals. So simply put, mineral alignment simply means the minerals are forming lines, zigzag line, like a zebra, if you know that animal. And then non-foliated simply means there is no evidence of alignments of the minerals, or the minerals forming any lines. All right, next we're gonna look at grain size. Grain size here is, give me a minute, I want a highlighter. All right, so grain size here, which is this column, you can see fine to coarse, medium to coarse. They have various grain size. After that is composition. Composition simply tells you the kind of minerals that rock is made up of. Once again, rocks are made up of minerals. It's minerals that come together to form rocks. Then next is the type of metamorphism. The type of metamorphism. So we have regional metamorphism and contact metamorphism. All right. So here you see that all these rocks that are foliated, they are all made out of regional metamorphism, which means it's a great region or a great part of the earth that is being affected by that kind of large scale heat and pressure, producing all this kind of foliated metamorphic rock. Then you have contact metamorphism. By far, this is the only rock here that is produced by contact metamorphism. These other three guys here can be regional or can be contact metamorphism as well. The next column we will talk about is comments. So comment just gives you a little more information about the grade of metamorphism, especially for the non-foliated guys. You see that the amount of metamorphism is increasing downward. What that simply means is a rock like gneiss experiences more intense heat, more pressure compared to a rock like slate. All right, so which means metamorphism increases downward. So hence you see high grade metamorphism here, and then for a rock like slate you will see low grade metamorphism. So it's important to pay attention to that arrow right there. Next after that is the rock name, which gives you the name of the rock that is being talked about. And lastly is the map symbol right here. So if you look at the map symbol, you will see that those that are foliated, you always see those kind of lines signifying that they are foliated, or you see those little nice lines there or even for the bending, you see the line forming a zigzag like a zebra. While for the non-foliated, you see they are all just scattered around, sort of. Okay, and that is it. Simple to read. So let's take 2 rock example and talk about details of those rock using this ESRT. Let's take a rock like gneiss, for example, right here. A minute. Gneiss. Okay, so what kind of metamorphism did gneiss undergo? You can just simply read it to the left. You can see that it underwent a regional metamorphism. What are the minerals that made up the rock gneiss? So if you continue reading, you see that it's made up of pyroxene, because it touches on it. It's made up of garnet, made up of amphibole, made up of feldspar, made up of quartz, and made up of mica. All right, so those are the minerals that make up the rock gneiss. Then continue reading. What was the grain size, or was the crystal size of that rock? You see that it's medium to coarse grain. And what kind of foliation does it show? It shows bending, that beautiful zigzag all around. And that's it. Let's take another example, one more. Let's take a rock like slate right here. All right, that's the map symbol for it. It undergoes a very low grade metamorphism. It undergoes regional metamorphism, and then it's composed of only one mineral because it does not touch any other mineral. It only touches on this mineral called mica. So it is monomineralic, which means it only has one mineral, and the grain size are fine, and it exhibits mineral alignment, which means when you look at the rock, you see those beautiful lines that has been produced. One more, and then we'll call it a wrap here. Okay, let's take a rock like marble. Marble right here will undergo was produced from the metamorphism of limestone. All right, remember, when something is metamorphosed, it's being changed from one thing to another. So the original rock that was metamorphosed to form marble is limestone. All right, the original rock for quartzite was sandstone. So it was sandstone that came in contact with heat or pressure to produce quartzite. All right, then for marble, the original rock was limestone, and limestone metamorphosed to form marble, and then undergoes regional or contact metamorphism, and then it's mainly made up of calcite, and then its grain size is fine to quartz, and you will not find any mineral lineation, which means when you look at it, you don't find any lines of minerals in it. And pretty much that's how you would use this ESRT page 7 identification of metamorphic rock. I wish you success in your practice. Bye for now.